Hello Shivam.
Good evening, sir.
Good evening. How are you?
Yes, sir, fine.
Okay, so is my screen visible?
Yes, sir.
Okay. So good evening everyone. Welcome to the live session on design of steel structures. My name is Saurav Kumar Singh and I am doing PhD from Department of Civil Engineering, IIT Kharagpur. Now first of all, coming to the basic teaching, Shivam, do you remember I have told you in my last live session that we will deal with failure, how failure of bolted joint happens in detail. So now we will discuss it. So as you can see here from this figure that failure of a bolted joint can happen because of failure of the bolt or because of the failure of plate, means any one of from both of them, if any one will fail then the joint will fail. Okay, so how bolt will fail? Bolt can fail in shear or in bearing. Like that, plate can also fail in shear, bearing, splitting or tearing, or we can also say it as tension failure of plate. So now moving further, so first of all we will deal with failure of bolt. So first is shear failure of bolt. What will happen in shear failure of bolt? So let us understand with a diagram. So let us suppose this is the bolt or rivet and this is the shear plane. So what will happen? You all know what will happen in shear failure of bolt. Can you tell me?
Sir, shear force is acting on the bolt and it leads to failure.
And how failure will occur?
At the shear planes, at the thread or at the shank portion.
See, if this is the shear plane, then tendency of the bolt will be to get cut into two pieces from the shear plane. Let me draw a neat and clear diagram. So this is one plate and this is another plate, and let us suppose we have made the connection through bolt. So here we can see that how many number of shear planes are there in this connection?
One.
Yes, one shear plane. So this is the shear plane. So when load will act on this connection, so tendency of the bolt will be to get cut from this place. So when load is acting like this, so this is the shear plane. So from shear plane bolt can cut into two halves. So this is how failure will occur when we consider shear failure of bolt. Now second one is bearing failure of bolt. What will happen in bearing failure of bolt? So it is written here, bolt will go out of shape from circular to we can say elliptical. So see here, this is the bolt. So when you will apply tensile loading, means you are giving tension, so what will happen? So in this case, tendency of bolt will be, means it will distort. Within this, if I can make this bolt diagram. So original bolt cross section of the cross sectional area of the bolt, if you will see, then it will be circular, but after that it will go out of shape, means you can say something like this will happen. Because of bearing, it will go out of shape, so its shape will, its cross section shape from circular, it will change. Okay, so this is how bearing failure of bolt will occur. Now again, coming to the failure of plate, in how many cases plate can fail? Plate can fail in shear failure, means cracks develop parallel to direction of force. So here I am having one diagram. So here you can see that for shear, you can see here in figure number 1, this B, figure 1B. So here you can see that, let me draw shear plane. So when loading is acting like this, so parallel to this, these are shear planes. So what will happen? Tendency of the bolt is to be, not bolt, we are now dealing with plates. So here what will happen? So plate will experience shear, and due to this shear, this type of failure can happen to which is parallel to the force applied. So when I will erase it, this shear plane, I am erasing this shear plane so that you can visualize it. So here you are seeing now, this is the bolt hole, and how failure happens? So failure is happen by this is damaging from this plane, and from here it is damaging. So this is known as shear failure of plate. Now second is bearing failure of plate. So in what happens in this, plate is pushed forward by the bolt. So figure 1C, here you can see that what is happening. So this plate gets distorted, means when bolt pushes this plate, so due to pushing effect of this bolt, this plate get distorted from here. Okay, so this is known as bearing failure of plate. Now again, splitting failure of plate, and last one is tearing failure or tension failure of plate. So here you can see that this is cleavage, so this is tearing failure of plate. So this happens because of the diagonal, when you are applying this tension, and if it will act like a, means diagonal tension case prevails, then in this case what will happen? Your plate will fail like this, your plate will get break from this point, and it leads to the failure of the bolted joint. And perpendicular to this loading plane, means you are applying load in this direction and this plane. Let me draw this. So I am talking about this plane. So this plane is perpendicular to the load acting in which direction. So here you can see that in this plane what will come? Tensile stress will come on this plane. So because of this, what will happen? Tendency of the plate is to get damage from this portion. So these are the 4 types of failure which can happen in plates, and 2 types of failure which we have already solving numerical problems, and we have already studied in our video lectures that how bolt will fail. So now question comes that in the design of bolted joint, we only consider, you have only considered shear failure of bolt, bearing failure of bolt, and tearing or tension failure of plate. Only these failures we consider, and these 3 failures, shear failure of plate, bearing failure of plate, and splitting failure of plate, we don't consider, means we don't design for this. So Why is it so? So come here. So you know that in my last live session I have told you that by providing proper end distance. So what is the end distance? From the video lectures you remember that if this is the plate and if load is acting like this, means in this direction, if load is acting, then in the loading direction, this distance means center to center distance between two consecutive bolts or rivets is called pitch, and distance of the center of the bolt and to this edge of the plate, this distance is called end distance. Here it is mentioned. And perpendicular to the direction of force, what is it is called edge distance. And this distance means distance between two bolts, consecutive bolts, is called gauge distance. So by providing proper end distance, we can prevent those three types of failure which we have seen here. Means only this failure we cannot prevent by providing proper end distance. So in this case, what is the end distance? So this distance is the end distance in this case. So by providing the required end distance, we can prevent this failure, and this failure. So these type of failures can be prevented by providing proper end distance. So that is why we are already providing proper end distance. So that is why in our design we don't consider these three types of failure. So one of the student on the discussion forum has asked a doubt related to this, that he asked me to design the gusset plate for these types of failures, but in I have replied there also that in our case we don't consider these types of failure, only tension failure we consider, because these type of failures we can already prevent. So in the design of bolted joint, we only consider shearing and bearing failure of bolt and tearing failure of plate. Now second note is very much important. In the design of bolted joint, we have to ensure that shearing and bearing strength of bolt is always more than tearing strength of plate. And why is it so? Because connection failure is more dangerous than component failure. So what actually it wants to say? Can anyone explain this line?
Sir, can you please repeat that
Yes,
sentence?
I am showing this slide again. Please read this note 2 again, and please explain what this note 2 try to explain.
Sir, I think it means that the bolts under sharing and bearing, it must able to resist the sharing and bearing, because connection failure is more dangerous. Because if the connection fails before the component failure, then the whole purpose is of the connection is just is lost. Are you getting what I'm trying to say?
Yes, I am getting. Yes, you are saying correct. Means when connection will fail, if let us suppose this is the frame structure and this is the joint and this is the joint portion. So if let us suppose your connection will fail, means at this point your connection fails, this point your connection fails, then what will happen? Your entire member, means this member, will fall down, okay? And falling of this member can lead to the means what you can say, it cost life. Means if anyone is standing below this member, then he will die or badly injured. So that is why we means provide a very good strength in the connection. So in practical purpose, in practical cases, we want that before connection failure, this member will bend, means try to deflect, or it can show some failure symptoms, so that after seeing the deformation, can you tell me that why we go for under reinforced section, and why it is said that we should not design for over reinforced section? In RCC, you have studied na, that we should design for under reinforced section and not for over reinforced section.
Yes, sir. In case of for the ductile failure, to prevent to have a ductile failure, we go for the under reinforced section, and in over reinforced section, it is not a ductile failure. The concrete is brittle; it just breaks out in compression. So that's why over reinforced section is undesirable.
Yes, what happens in over reinforced section, we don't get any alarm before failure. If we have designed our section as under reinforced, then what will happen? First of all, your steel will try to show the deformation, means your steel will reflect that deformation is coming, so you can see your members that it is bending or deflecting, so you can see from your eye, and it gives you alarm before the failure. But what will happen in case of over reinforced section? Steel will not fail first, your concrete will fail first. So when concrete will fail first, so no sign or no alarm will be given, so directly your member will fail. So that is why we prefer under reinforced section. So same case is here also. You can understand like this, ki if connection will fail, then entire member will fail down. But if this member will fail first, means it will give us alarm, so that we can check it for the deflection, or we can do whatever we can say, that means repairing work or maintenance task can be carried out. So that is why note 2 is very much important for practical purpose when we are going for the construction, means implementing our design on the ground basis. So we always prefer that it should be shearing and bearing strength of bolt is always more than the tearing strength of the plate. Okay, now coming to your
Sir,
doubt, Shivans. Yes, please.
Sir, in the question that why we are not designing for bearing tearing of the gusset plate, sir, in the gusset plates, uh, we have some resultant forces. Means if 2 to 3 members are acting, then we have a resultant force. So,
Okay.
sir, do we have to check the means in x and y direction we have to check the resultant forces?
No, no, no. We don't check like that.
Because when we study about the trusses, we go for in x direction and in y direction method of joints, we go for that. So don't we need to do that thing uh,
No, see,
to
actually, in practical purpose, see, here we are talking directly, but when you will see the practical purpose, then in that cases, gusset plate is quite heavy. Okay, so that is why in any of my live session, I have also told that why this there is need for restricting the size of the gusset plate, because if you will increase the size of the gusset plate, when you are going to increase, it will cost you a lot. So that is why we prevent it, because gusset plates are heavy members. Okay, so that is why we prevent it. And wherever you are designing the connection, so in that part we are checking all those criterias, means let us suppose that 3 members are meeting at a joint, means on a gusset plate 3 members are meeting. So we are only dealing with, in any one of the numerical problem, we are only dealing with the, means a single portion. We are not considering the entire portion. So in the design of the gusset plate, when you will I don't know whether it has come to your video lectures or not, but in the design of gusset plate you will see that if several members are coming on a section, then in the question, in the long type of question, you will be asked for each member. Okay, so for each member we will check. So if at every position, if your connection is fine, then your gusset plate is fine, so no need to calculate for the final resultant. So have you means I
Sir,
don't know in which
can the
lecture.
combination of
Pardon.
sir, can the combination means we have principal axis and major principal axis and minor principal axis. Those things can they come into picture in gusset
See,
plate?
in gusset plate, what we try to do na means in the gusset plate, we every time try in the practical implementation, we or in the design, we try to make each and every force pass through a single point. Let us suppose this is your gusset plate. Okay, so uh, if this is a member, this is a member, this is a member, so like this we try to means each and every force means the line of action of each and every force will pass through a single point. This is the common point. In practical implementation, there might happen that it will not implement like the same, means some error will be there, but theoretically we try to pass the each and every force which is acting on this gusset plate, so we try to make them pass through a single point. Okay,
Yes, sir.
now in the last live session you have asked this doubt, means doubt related to the position of neutral axis for the HSFG bolt. For that you have also uh, shown one figure, means one numerical problem of the Bhavi Katti book. Okay, so I went through 2 3 books. So in first of all I will discuss about the Subramaniam's book, which is the standard book. So I went through that book and I don't find means any type of this criteria that neutral axis is passing from the middle. For the any of the cases they have not mentioned like that. So it might happen that earlier it should be like that, but now they are taking as h by 7. So this they are taking. So further in detail I want to introduce it. This figure is taken from L.S. Negi's steel structures book. So here they have told, 1 minute. So here you can see that they have provided this diagram. So what they actually trying to say, in the case of HSFG bolts, so initial tension is induced in the bolt. Do you remember? In the HSFG bolt, by giving proper clamping, means tightening the nut, we are trying to develop initial tension in the bolt. We have
Yes, sir.
discussed
Pre-tensioning.
we have discussed this in during the discussion on HSFG bolts. So pre-tensioned bolts, so clamping force is very high in those connections. So Alice Negi means in this book they are trying to say that if you will see this connection then due to this initial tension which is developed in this bolt, means because of the proper tightening, means very tight tightening, so that is why this plate, means this bracket plate and this column flange will remain in contact with each other. Okay, in the case of HSFG bolt. So they are saying that in the case of HSFG bolt, this your column flange and this bracket plate will always remain in contact with each other. Okay, so that is why they are taking the distribution of stresses like this, which is shown in figure C. So this C is the stress diagram for when bolts are initially tensioned. Okay, now when you are considering ordinary bolts, means in ordinary bolts related to those bolts in which pre-tensioning is not provided, so no initial tension. So in that case what we assume that upper part of this portion, means let us suppose we don't know where neutral axis will lie. In this case we don't know, for right now we don't know where neutral axis will lie. So what will happen here? So above neutral axis it will be in tension and below the neutral axis it will be under compression. So above neutral axis where tension will come, so it will lose contact with each other, means this bracket plate will lose surface contact with this column flange. So can you visualize this thing? In when bolt is not initially tensioned, means no
Yes, sir.
clamping force like that, means high clamping force is not there. So in that case above neutral axis what will happen, when because of the application of this load it will try to bend like this. So when it will try to bend like this, so let us suppose this is the neutral axis position. So above this what will happen, due to this bending, tension will come on upper side and compression will come on lower side, means below the neutral axis compression will come. So due to this what will happen, it will lose contact, means here this is the contact surface, so this contact surface will get break. So entire tension will be passed through this bolt. But in the case of HSFG bolt, means where initial tension is there, they are assuming that it is so much tightly packed that it will not lose contact with this part. So that is why you can see that the entire plate, means tension is carried throughout, means from here at this position they are taking it to, means this stress diagram has been started from this plate position and not from this bolt line. But in the case of this means stress diagram no initial tension case, here you can see that this stress diagram starts from the bolt line. So they are assuming that entire tension will be carried out with the, means transferred from the bolts. So that is why it for normal bolts we take depth of neutral axis as h by 7, but in case of pre-tensioned bolt, that is HSFG bolts, we take it as at the center, means at h by 2. But they have also shown, means in LS Negi book there is one example, you can go through that example if you find it. So in that example, one of the numerical they have solved from both the methods, from using this method, means your using this formula, means your stress distribution diagram is like this, and again they have solved using this method, means where bolts are, means sorry, these contact surfaces lose their contacts. So with both the cases they have solved, but in this case the answer which we get in this case is on the conservative side, means if you will design according to this, means following this, then strength of the bolt whatever you are getting, you will be on the safer side. But in this case, means see, this case is more appropriate, means when you are going to see the practical, means in practical if you are going to measure how much tension is coming, how much compression is coming in the, means in the connection, so when you are going to measure and when you are going to design it theoretically, then your answer will be, means this answer will be more closer to your what you will get from the experimental values, and this value is far away from your experimental values. But this value is the more conservative value. If you will design like this, then you will be on the safer side, means you are underestimating the connection and providing, means connection very gives
Means
very
large
good
number of
strength
bolts
to
are
the
being
connection. Yes, please.
large number of bolts are provided when the center line is chosen.
So
Are you trying?
That is why I am saying na ki means in this case what will happen, you will provide more number of bolts, so more number, but in real what is happening means, let us suppose you are providing 8 number of bolts in this case, but in the real case if you will solve your example using this case, so it might happen that only 6 bolts will be required. Okay, so here cost of connection is more, but you are on the conservative side. And furthermore, when you are going to solve it theoretically, so in most of the cases, if you are going to solve your problem with using these formulas, so it will be easy, means your formula is easy, but in this case your formula is tough. So in order to save the times, earlier means people used to directly use this formula, not this formula, but in Subramaniam book, nowhere this type of thing is has been discussed. They are talking only about this thing, this second case, because when you will see now, means practically when you will see, let us suppose the tension part, I'm agree that plate will not leave the contact surface, means both the plates will be in contact with each other in the case of initial tension bolts, means when bolts are initially tensioned then plates will be in the contact. But if you will try to visualize that how load will transfer, so in tension means, see in the compression part, this bracket plate is compressing this column flange directly, so your bolts are not transferring this compression in this case. But in the tension case, any of the case will there, so the tension will be passed through your bolts only. Little bit of means, can you visualize what I am trying to explain here? When it will
Yes,
bend,
sir.
it will in practically it will not leave this contact, but tension will be transferred through these bolts only. Tension force will not be transferred directly from this column flange to this bracket plate. No, this cannot happen. So that is why I think Subramaniam is not discussing about this thing. They are only saying about this thing, and they have told that if you means in some of the cases we go for conservative design, so only line they are adding like this for about the conservative design, and this is the conservative design, but on the same hand it will make your connection uneconomical.
Yes, sir.
Now coming to the previous year assignment questions. So question 1, maximum slenderness ratio for a member carrying compressive load resulting from dead loads and imposed loads is. So this is the direct codal provision. So do you remember, in any one of the table it has been means given? Do you have
I
IS
think
code book in front of you?
I have my notebook. I have, sir, it is 180.
Okay, 180 is the correct answer. So Swetank and Anusha, you can also participate in these questions. So if you have a soft copy of IS 800, so you can open it and you can see that in table 3 of IS 800 2007, its value is given. So from there, this question has been directly asked. So correct value is this 180. Now second question, which of the following section come under buckling class C? Consider buckling about any axis. So here in the question they are not restricting that you have to consider buckling about YY axis, or consider you have to consider buckling about ZZ axis. No, they are saying that in any of the axis. So what of which of the following section come under buckling class C? So first option is channel section, again T section, third is hot rolled hollow rectangular section, and last is solid rectangular section. And here is the code which you have to choose. So I think in means IS 800 2007 in table
Table
10.
10. Table 10.
Table 10 you can see it.
Uh, so T section is coming. Built up section is there. Sir, it is welded box section. Then welded eye section. In sir,
Yes, yes.
Sir, there are means for rolled eye section and welded eye section, there are different cases as
No,
well.
no, no.
So
Check it like this. Means channel section comes under which class? They have also made a diagram
C.
there. Channel section comes
Uh,
under buckling class C. So first one is correct. Okay.
Answer is option C.
So first one is correct. Now check for T section. T section comes under which class? Which buckling class?
C.
This also
So this also comes under C. Now rolled hollow rectangular section.
It is talking about rolled section.
Yes, hot rolled hollow rectangular section. So I have checked for hollow. There is one section given.
A and B.
class A.
Please say it
Class
again.
A. Class A. It is
Class
class
A.
A.
So okay, so this is wrong. Option 3 is wrong. So from 1 and 2 also, and 3 is wrong. So from here you can see that 3 is not here. So 1 to 4 is there, and 1 3 3 is not again there. 1 and 4. So from here also we can say that option B is correct. But then also please check for solid rectangular section. It will also show buckling class C.
Yes, sir.
Okay. So whenever you are going for appear in competition exam, na Shivans, the students which are going to appear for competitive examination, so always see that for each and every option, it might happen that you don't remember the things. Okay, so just don't leave your questions directly. So first of all, try to check the options. From the options, it happens sometime that if let us suppose you only know answer for about only two sections, so from the option it might happen that from these two only you will get your code, and you can guess that what is the correct option. So never be in hurry. Read question at least for 2 times, and if there is confusion, then you can also means meticulously check for the options which are given. And most of the time for the gate questions, I mean most of the time students what students do, they directly see the question and fatafat solving the answers, and after that they tick the option, means, and the wrong answer is waiting there, means uh, whatever effort they are giving to prepare the correct option. Okay, so same effort they give to prepare the wrong answer in the case of gate examination. So that is why in objective examination gate is considered as the toughest examination, because when you are missing something, you have not seen anything, means up to decimal point this, up to 2 decimal point, or up to 3 decimal point you have to give answer, and just you find out something and you will mention it like this, and first option is waiting for you, and you will hit it and it will be wrong. So that is why in the case of big competitive examination, not for the JE level examination but for the means gate engineering services, read questions at least for 2 times and then only uh, give your answer. So option B is correct. Now coming to question number 3. A structural steel tube has a minimum radius of gyration 25 mm. So minimum radius of gyration has been reported here as 25 mm. The unbraced length up to which the tube section can be used as a member carrying compressive loads. So here see, means you have to detect the keywords. So 1 minute. So first, what is the first keyword here in the question? This minimum radius of gyration 25 mm is the first keyword. Second is the unbraced length up to which the tube section can be used as a member carrying compressive loads. resulting from dead loads and imposed loads is equal to. So right now in above question, in this question we have already seen here what is the maximum cylinderness ratio for member carrying compressive loads resulting from dead loads and imposed load. So you have given answer as 180. Okay, so here cylinderness ratio will be equal to 180 because same condition is there and minimum radius of gyration is given and they are asking you to the unbraced length, so they are asking you the length. So please calculate and report. Cylinderness ratio you have to consider 180.
So D option.
4.50. Correct. So this is the solution. Students who don't get the answer or if they have not solved it, so please see here maximum cylinderness ratio for compression member is equal to 180, unbraced length is equal to 180 into 25, that is equal to 4500 mm is equal to 4.5 meter. So we know now cylinderness ratio is equal to length upon minimum radius of gyration. So minimum radius of gyration from this side they have taken this side, so 180 into 25. Now coming to the long question, so please open your calculator and your notebook. So an ISA 100 cross 100 cross 10 mm is used as a strut member. Okay, see in some time means you will not get here mm written over here. Okay, so dimension will not be written, means unit will not be written here. So that is why you have to be little bit familiar with your IS code book and your means steel tables, so that you can know that in which unit these things are given. So we know that in steel table or in our code book it is given in mm, so that is why 100 mm cross 100 mm cross 10 mm, this is angle section, is used as a strut member. So first of all tell me the definition of strut. What is strut?
So strut is not vertical, it is at an angle and it is used in truss as a truss member and in the bracing systems.
Yes, fantastic, you have remembered it correctly. And uh, you need to means column. I want to ask one more thing, what is the difference between column and stanchion? These two things are compression member. Column is also a compression member and stanchion is also a
Sir,
compression
in
member.
steel buildings column, steel buildings it is called as,
Yes, you are
in
saying it
RCC it is
correctly. Please
called
say.
as what sir?
You are going correctly. Please tell the definition.
Okay. In steel buildings, the columns are specifically being termed as stanchion, and in RCC buildings, the pillars are known as columns.
Yes, fantastic. So here they are saying that there is a strut member. So if it is a strut, so this is compression member problem. So is used as a strut member having an effective length of 3.2 meter. So here they are already terming it as effective length, so no need to calculate the effective length. So that is why they have not even given the end condition. In sometimes in the competitive questions or in exam also you will see that effective length will be given, and along with that they will also give you the end conditions of the means strut in order to confuse you, so that you can again calculate it with applying the factor and you commit the mistake and report it as wrong. So that is why you have to means mark out these things. So effective length is given 3.2 meter, so no need to calculate effective length. Further, calculate the strength when it is connected by one bolt at each end. So it is talking to calculate its strength, means strength of the strut member. So assume hinged connection. So why it has been given 1 bolt or 2 bolt? Because your connection means how many bolts are used, so based on that you have to calculate the value of the constants and assume hinged connection. So this term is also will be used to determine the value of the constant, which will come into picture in the formulas. And relevant properties of ISA 100-110 are given. Area is equal to 1903 mm square, RVV is equal to 19.4 mm. So RVV is radius of gyration among about weaker axis, and B1 B2 because this is equal angle, so that is why B1 is equal to B2 is equal to 100 mm, and thickness of the angle T is equal to 10 mm. And these are the options. Please write down the important values which you will be required to solve the numerical problem, and please solve this question. So basically you have to calculate the value of P. Strength is equal to stress into area. So for compression member we report it as the value of FCD and into area. Area it has been given here in the question. You have to calculate the value of FCD. Now first of all, see, value of FCD depends upon what parameter?
Sir, it depends on the effective non-dimensional effective slenderness ratio.
Okay, the value of phi and lambda. So you have to calculate the value of phi and lambda first.
Yes, sir.
Equivalent slenderness ratio lambda E is equal to root over K1 plus K2 lambda VB square plus K3 lambda phi square. So in calculation of equivalent slenderness ratio, you will need to first of all means take out your code book and determine the value of K1, K2, K3, and find out the value of lambda VV and lambda phi, which will be used to calculate the value of equivalent slenderness ratio. So lambda VV is equal to L upon RVV upon epsilon times under root pi square E upon (250) and lambda phi is equal to B1 plus B2 divided by 2t upon epsilon pi square E divided by 250. and epsilon is equal to root over 250 upon Fy. So here L is given in the question 3.2 meter and RVV value is given as 19.4. So bring them in a common unit. Epsilon value you have to calculate. E for steel, Young's modulus for steel we already know, 2 into 10 to the power 5. So each and everything is here. What is the value of Fy?
250.
So value of Fy is 250. So epsilon is equal to 1. Epsilon is coming equal to 1. So now put all these value and first of all report the value of lambda Vv.
Lambda VV is 0.1174.
No.
So it is getting wrong.
L value, what is the value of L you have taken?
3.2 into 10 raised to power 3.2 into 1000.
Okay, RVV 19.4.
Yes, sir.
Epsilon is 1, no need to take it, upon pi square. So pi
pi
square
square
is
into
there.
pi square 2 into 10 raised to power 5.
Okay, upon 250. So 250 is also under root. So calculate it once again.
250 and 250. Oh, okay. Yes.
Value of epsilon is root over 250 upon 250, that is equal to 1.
$88.85
No.
Oh, sorry. 1 minute.
Take your own time. No need to be in hurry. Because if you will know each and every concept and if you will commit calculation mistakes, then everything will be means gone.
Sir, 1.856.
Yes, correct. 1.856. So lambda Vv value, this we are getting as 1.856. Now calculate the value of lambda phi. Take your time and calculate. Pardon?
1.779.
No, please check your calculation once again. What is the value of B1 you have taken?
100
And B200. Okay. So please check your calculation once again.
Uh, 0.011.
No. It is 0.1125. Please check once again. Zero point 1125.
Sir, B1 plus B2 is 200 divided by 2 times the thickness is 2 into 10. Okay, I'm getting that's
200 upon 10 upon root over pi square into 2 into 10 to the power 5 divided by 250.
0.1125.
Yes, correct. Anusha, have you got the same answer?
Yes, sir. 0.125.
Okay, thank you. Okay, so now check from the codebook value of K1. Tell me value of K1. See,
1.25.
condition is
K1
given
is
here.
1.25.
Uh, Wait a minute, let me check. So K1 you are saying K1 is equal to 1.25, K2
Uh, K2, yeah,
and K3.
60.
Okay, so put all these three values here and use bracket here. Don't calculate this value directly, use bracket and report the value of lambda e. Take your time and calculate.
1.93.
1.93, yes. So Shivam, are you getting value of lambda e is equal to 1.9317?
Yes, sir, I'm getting.
Okay, so now calculate the value of lambda phi. Oh, sorry,
Lamp.
lambda phi we have already means calculated. Now we have to calculate the value of phi.
2.75.
Yes. So how you get the value of alpha in this phi?
Buckling class C.
It is Buckling class C.
Okay, so which table you have used? Means I want to ask that value of imperfection
Table
factor
10.
alpha is given in which table?
Table Table 7.
Yes, table 7, correct. So alpha value we are getting as 0.49, which is given in table 7 of IS 800 2007. So after putting all these values, we will get value of phi as 2.789, and now calculate the value of FCD, which is equal to
Which is 47.31.
47 point.
31.
Yes, yes,
31.
correct.
And result strength is 90 kilonewton. 90.04.
Yes, correct.
We are getting.
So value of P will be equal to the FCD 47.34 into area, which is given here 1903, which will be equal to 90.08 kilonewton. So in round figure it will be 90 kilonewton. So for the students who have not solved this question, and you can go through this slide later on, although each and everything has been solved here. So this is the entire solution. Now coming to question number 5, calculate the minimum radius of gyration for two equal angle ISA 200 cross 200 cross 12 placed on the same side of gusset plate, and relevant properties of the section is given here. You can note down and report the answer. Actually, I have made figure in another slide. So these are the same angle sections 200 cross 200 cross 12, and they are on the same side of the the plate. So this is YY axis, this is overall x axis of entire this connection. So in final also see, for this angle its centroid is here and here. So final, what is the YY axis of this section, or this section will be the final YY section of the entire this design, but X will change because earlier X axis was passing through here for this member, and for this member X axis was passing from here. So I am reporting it as X1 X1, and this was X2 X2. So in the final built up section, so in this built up section you can see that this line is passing through here, means between the center of these two connections. So you have to calculate IXX about this line, and IYY will be same, which is given here 1788.9. So calculate this XX. We have already discussed in one of the live session that it is solved by parallel axis theorem, using parallel axis theorem, in which means you can IX1 X1 plus A H square. So area of single member is given here 4661, and H square is the distance, means here how much distance is X, so Cx equal to Cy equal to 53.6. so this distance is 53.6 and this distance is 53.6. so value of H is 53.6 and Ix is already given here, and as these are two sections, so multiply by 2. So put the value and get the result. So are you able to understand this solution?
Yes, sir.
Anusha, do you understand?
Yes, sir.
Okay. So R minimum will be minimum of Rxx or Ryy dash. So this we have calculated Rx dash we have calculated as 81.92 mm, and Ry is same, which is reported. So earlier also y axis was passing from here, and for this built up section also y axis is passing through the same position. So that is why Ry dash is same as 62 mm, and minimum of these two is 62 mm, which is equal to R minimum. So correct option is A. So in the previous year assignment questions, there were 10 questions. So 5 questions I have discussed, and remaining question 6 to from question number 6 to 10 will be discussed in the next session of Mr. Anandrup Lahiri. So we will meet again there.